Hey, I'm Greg, and this is my recording of the word search kata. Um, I'm using JavaScript in Visual Studio Code, and I'm using Jest as my test test engine of choice. I do have a couple of other packages installed, Ddent, which I'll talk about here in a minute, and Jest Extended, which I ended up using for one of the assertions that I want to make farther on down the road. I've already gone ahead and typed in the acceptance test that describes the way that the kata works. Basically, we have a bunch of letters. We have an input body that consists of a bunch of letters in a grid and some letters that we would like to find in that grid. And what we're supposed to do is produce output that contains the locations and coordinates of those words in the grid. And, the words can start in any direction. So like bones starts at row 0, column 0, row 6, BONES, and so forth. Fairly straightforward, but there's a lot of depth to this kata, and I've been having a pretty good time working with it. So let's get started. I'll go ahead and run Jest. NPX is a thing that tells it to run a binary that's included as one of my node packages, and the -- watch flag tells it to run continuously and run again whenever any of the files changes that's been saved. So as you can see, the acceptance test does not pass because I'm returning undefined. And I've gone ahead and implemented the minimum amount that I do to make the test fail for reasonable reasons. So I'm going to go ahead and X that out, and we'll get back to it. So I want to test some more basic things to start off with. And I want to start with parsing the input body. The implementation that I'm going to do calls for a thing called a cell, which we'll look here in a second. First, we're going to make a new puzzle. And here's where I get into the Ddent plugin that I talked about. In order to make these grids look like this, JavaScript doesn't have a great what's the word I'm looking for? Here docs structure in it. You can use these backticks to do it, and it will put the new lines in and so forth, but it will include the indentations and all these extra new lines and blank spaces and so forth. And what Ddent does is it just cleans all that stuff up for us so that we get the puzzle without extra junk. So we're going to Ddent and backticks, and in here we can just start typing characters and it works. I'm going to make a 2x2 puzzle, just A, B, C, D. And I want to assert that the puzzle.cells is an array of cells. One with A at coordinates 0, 0, and so forth. And let's see, the first coordinate is the X, which row it is, so these stay the same. And cell is not a thing, because I haven't written anything called cell yet. So one of my programming heroes is a guy called Gary Bernhardt, and what he said once about test-driven development is that when the test is failing, you are allowed to do only two things. You are allowed to make it pass, clearly enough, or you're allowed to change the failure message. So I'm going to try to take small steps that change the failure message along the way. So right now I haven't done anything to it because there is such a thing as cell, but it's not exported. So I have to get it in to the other file. Okay. It turns out I already have the import here. I had started with that. little bit of cheating. Oh well. So now it's telling me expected an array with junk and received undefined. I don't like this array of junk. I want the cell to actually say what it has in it. So I'm going to change the failure message by adding something to the definition of cell. And I'm just capturing the input from the constructor. And that will cause my failure message to change in such a way that it's more interesting. Okay, now I'm receiving undefined, and I don't like that very much, so let's change that message. I'm just going to have it return an empty array. Okay, now I get a nice failure message. This is kind of what I wanted. I can see that I expected this nice construct, and I got an empty array. Now I can start working towards actually building this thing. So the input to the puzzle consists of lines with comma-separated characters in it. So first I have to split along lines. Okay, we're getting somewhere. That's a little bit better. It's clearly not all the way there yet. Next, we're going to flat map. I could do a map here, but I know that I'm going to have to go 2 dimensions deep into this. I have to transform the lines, and then I have to transform each character in the line. So I'm just going to go ahead and jump straight to a flat map. And let's see, I have the line, and I have the index of which line it is, which is the y-coordinate. And I'm just going to go ahead and split the line. Okay, so by doing the flat map, I get a single array that has A, B, C, D in it. If I'd done a regular map, I would have gotten an array with A and B, and then an array with C and D. Flat map just flattens it. Okay, but this still isn't exactly what I want, and I want to map these. The second argument to the function that map takes is the index into the array. We're going to use that a lot in this kata, like all the time. So now I have an x-coordinate and a y-coordinate and what the character is, so I can just make a new cell. Oh, not. Almost there. What did I do wrong? Yes, of course. So that's 1, 0. Okay, that's better. I do that about half the time. I don't know why I can't seem to get that part straight in my head. Okay, so now I have a list of cells in my kata, in my puzzle. This code is a little dense, I admit. I'm not sure what to do about that. I haven't yet come up with a good way to make this clear. This kind of thing is relatively straightforward. It happens a lot when you are working with this sort of functional stream programming style. We're going to see a lot of it, and I welcome ways to make this clearer if anybody has any suggestions. Okay, so we've got cells. I want to move on to the meat of the algorithm. And the way that this algorithm works is I want a thing called a finder, or some kind of class, that what it does is it takes the puzzle, or the list of cells from the puzzle, and a direction. And when given a word, it tries to find things that are sort of like that word by looking in the direction that it was supplied and matching on the first character of the word. And that's not very clear, but hopefully it will be clearer when I get to some examples here shortly. So let's make a puzzle that will show this off. And let's just do 1, oops, 2, A3. And I want this to go horizontally, so x is 1, x increments by 1, and y increments by 0. Okay, and what's going on here is that I started with this finder looks by moving right. It finds the first character of the word, and for each matching location, in this case there are 3, it starts there and moves in the direction that it was given. And so that's all I want it to do right now. And we'll see how this plays in to the actual algorithm later. Okay, so there's no such thing as a finder, because I have not written it yet. And there's no such thing as candidates for. And okay, so now I can actually start implementing it. Well, first we can start by just returning what we're expecting. I did this wrong. I did the assertion wrong. So let's return an empty array for now so I can get back to my assertion. What I actually want to do, what I want candidates for to return, is an object that contains the list of cells along there. And I don't want it to be just an array of cells. I actually want an object, and that'll come into play later. But I want to be able to map to toWord on the object, and I want that to equal the thing. Okay. So I'm still getting the same result. Expected this, but got an empty array. JavaScript doesn't care that there's nothing called toWord because I haven't actually tried to call it on an object yet. If I do pass an actual thing in there, which I will here in a second, now it will be mad that there's no such thing as toWord. And what I want a path to be is a thing that takes in a list of cells and stores them. That's all. And toWord on it is just mapping the cells to their character and joining it up. You could argue that I'm doing this without a test, but I'd say that the test that I'm writing right now is the test for this. Okay, and now I can finally hard code my first test to pass. Okay, so I got A1, but this is dumb and I already don't like it, so I'm not going to do that. What I'm going to do instead is go ahead and work on the actual implementation. I have to capture the puzzle. and the direction. I don't care about the puzzle itself. All I care about is the cells. I'm just going to pull those out. And I will use X and Y later. Okay. So I want the starting cells. And those are all of the cells that have the same letter as the first letter of the word that I'm looking for. So cells such that the cell's value is the same as the first character of the word. And I'm just going to get rid of all that. That's pointless. Let's see how that goes. Okay, so now I have 3 starting locations because the puzzle in question has 3 A's in it, and I'm searching for a word that starts with A. So these are my 3 starting characters. And right now all I've done is build a path that consists of only the thing that I started with. Pretty dumb, but again, what I'm doing is I'm having the error message in the test change, and the error message is evolving in the direction that I want it to. I am getting some feedback as I do this. I'm not just working in a vacuum. My tests haven't passed in a little while, but I'm okay with that for now. And let's give more stuff in here. And I'm going to need another cell. And in particular, I want the cell at a particular coordinate. So I'm going to just make a method that does that. And the particular coordinate that I want is that one. Cell add is pretty easy. I just search, brute force search through my list of cells to find one that matches. Okay, so now my test is passing. It's pretty naive. I'm just taking all the start locations and moving directly right from them. I'm not using the direction that I was given because my tests don't make me. So let's try a different direction. Should I do it in the same puzzle? Let's try it in the same puzzle and see how this goes. And let's go southeast. And again, I want to map them to Word. And I think this is going to give me A2, A3, and just A, because there's nothing down there. So let's see what happens. Okay, it didn't work because I'm only moving directly to the right and I'm not paying attention to the direction. I got A1 and I did not get A, which is as expected. My test is failing because I haven't written that code yet. So what I need to do is why did that not work? I expected that to work. Still got A1? Why? Well, start checking my assumptions. Oh, okay. I see. So they don't actually have the right y coordinate, probably because I wrote my test wrong. I built another finder, but I didn't actually call the method on the other finder. Fair enough. Okay. Let's get rid of that console log. Okay, now it's saying it can't read value of undefined, because when I started at this A and I went diagonally down and right, it found nothing, and then it tried to do stuff on it. So I want to discard those nothings. I don't really want those to be there, and there's a number of ways to do this, and for the moment I'm just going to do that here. So what's going on here? I'm saying I want this.cells to have the cells that match this filter, and I'm going to give it a function. And the particular function I'm using to filter here is the constructor for a Boolean. That is, I'm going to take the argument, convert it to a Boolean by building a new Boolean object out of it, and if that Boolean is truthy, I'm going to keep the original object in here, and if it's falsy, I'm going to discard it. In particular, undefined is falsy, so when I pass it through the Boolean constructor, I get the Boolean false. So it won't pass. So the undefined will not pass through the filter here. This is a construct that we use sort of often in this kind of construction. This just says dump nulls and undefineds. Okay, so my test is passing. I'm a little sad now that I wrote this as a separate test, so I'm going to go ahead and pull it out. And this just can close. Okay. There's a couple other things that we need to do. Right now, we're only doing 2 characters. We need to do longer ones. Uh, Things that are longer than 2, but only as long as the actual word that was produced. So let's make a puzzle. And for once, I'm not going to do any of this dedent nonsense. I'm just going to do 4 characters. Let's see. I have to. It is for ABC, and I have to map it to Word. Okay. So it's saying it wanted ABC, but it only got AB because we're only doing 1 character. Fair enough. And the way we do this is we have to get a character for each character in the word, basically. And the way we do this is we start with the characters in the word. Now, unfortunately, a string in JavaScript doesn't give you an easy way to get at its characters in a sensible way. So I'm just going to go ahead and make an array out of it, out of the character, out of the string. And again, in this particular case, I don't actually care about the character. I care about the index of the character into the array. And I want the thing that I want to get from the character is this line. I want the cell at a particular location. It's I times that, and I times that. And there you go, it passes. So what are we doing here? For each index into the word, we are saying I want to start with the particular start location for that I'm paying attention to right now, and I want to move this many in the direction that I move in this finder. So if it's the 0th character of the word, I want exactly this. I want the cell that's exactly the same as the start cell. if it's one character in, I want to move, in this case, one down into the one to the right of the start cell. If it's two into the word, I want to move two from the right to the right of the start cell, and so forth. And as we know from previous tests, it starts from each start cell that it can find, and it discards cells if it falls off the edge of the puzzle, and it stops when it reaches the right length of the word. I think this is done. I think this is all we need candidates for to do, and all that we need Finder to do. All that's left to do is actually build some of these things and use them to find words. We can finally start writing tests on the puzzle itself. We're going to make a puzzle that makes it easy to test this. And I'm just going to do 1, 2, 3, 4, C for center, 5, 6, 7, 8. There's 8 directions. I should start at the center and find a word in each of the directions. And it doesn't matter what the second character is. I'm not going to find it, but I should find candidates in all the right directions. And again, I want to map it to word. And here's where I'm going to use the thing. I don't want to worry very hard about the order. I don't care about the order of these things. So I'm going to say to include same members as this argument, which is an array. So this is C1, I'm just going to do C1 a bunch of times. Four, 5, 6, 7, 8. Dang it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Candidates for is not a function. Fair enough. I put puzzle in the middle. I've been trying to put it at the bottom. So I'm going to go ahead and do that now. Again, I just want to get some fast feedback, so I'm going to return an empty array. Fair enough. So here what I'm going to do is I'm going to say I'm going to have an array of directions. And a direction is a plain old JavaScript object that has an X and a Y, and that's all. And I want to map over these directions. I'm going to fill that list out later. And what I'm going to do with each one is make a finder. This is the current puzzle. And oops, I forgot this part. And again, we want a flat map. And I forgot the word const. Okay. There's no such thing as finder. So here's a weird quirk about JavaScript. If you export it like this, it doesn't actually do the thing. like that. ES6 exports are nicer than this, but Jest doesn't play nicely with ES6 out of the box. You have to do work, and I have not bothered to do that work yet for this particular kata. Maybe I'll do it sometime. But it's done the thing now, and I got C5, which is the only one that I've done so far, which happens to be the one where you move right horizontally. So let's go some more directions. 2, 3, 4. Let's just move in the cardinal directions. Okay, now I've got 4, 5, 7, and 2, which it turns out are north, south, east, and west, moving from the center. And now we can move in the diagonal directions. 3, 4. There we go. So now we have candidates for the word in all directions. We still haven't done any actual word matching. Now it's time to do that. So here's where I'm going to actually use the paths that I've been returning this entire time and mapping to words. So I want puzzle.find. Maybe I should make a puzzle, huh? Let's go down, huh? And this is uh, 1, 0. No, this is all wrong. These are all 1s, but that's 1, that's 2. Okay, there's no such thing as puzzle find. Okay, now I have to actually export path. And path still not defined because I have to import path in here. Okay, and now I'm returning undefined, which is what happens when you don't explicitly return. So let's just actually build the thing then. This is actually pretty easy to implement now. We have candidates. We just have to get the first candidate whose to-word matches the word. That's it. That's all we have to do. So now we're in a position, finally, to go back to our integration test. Start working on that. Again, I'm going to work in the direction of, I'm going to make the, not going to build a bunch of small tests for this. I'm going to make the assertion, the error message change in more and more helpful ways as I go along. So the thing I'm looking at is this find all method. And let's just go ahead and let's see. What I get from the input is a line that has the words in it, and then a line that has, and then lines for the rest of it. So let's just do, let's split that up. The header and the rest of the lines. And let's return header. That'll let us get some quick feedback. The error message has changed. This is not right, but we can tell that we're doing something now that's moving in the right direction. Okay, let's get the words out of the header. Better. So now I have an array of each word that we're supposed to be looking for, and I can join them with new lines. That gets me a little bit closer to the thing that I'm doing, and I can add a little bit of formatting because I see there's supposed to be a colon here followed by the actual path that we took through the puzzle to find that word. So I can map it through some formatting function. And again, I just want fast feedback, so I'm going to do something dumb. But I can see that I'm constructing the answer piece by piece. My tests are still giving me fast feedback, even if it's not, the traditional TDD flow. Okay, so I've got something here. And notice I'm not actually using these lines, and I don't have any of this puzzle implementation that we built. It's time to do that. Now, puzzle expects to get the lines of the puzzle joined together into a single string, because it's going to split them. So I have to put these lines back together. And then I should be able to find the things. Let's see. My message isn't changing. Not great. I wish I could do better at that. And let's do... Okay, there's no such thing as path.print. So let's make it. Okay, it's just an empty string now. That's clearly not right. Okay, I don't actually need that. Wait, what? Oh, there we go. Okay, but now it's just calling toString on this cell method, and I can override that. Just convince you that I'm actually calling it. And now I can actually do a little bit of formatting here. There you go. Our acceptance test is passed. We found all of these words and printed out all of that output. And we moved the way through it. I've not done a whole lot of refactoring in the course of this. There's not a whole lot that I would want to do. Some would argue that some of these things should be extracted out. I'm not so sure. I think that in this stream programming style, it's reasonable to leave some of this stuff in line where it is, because it doesn't really make much sense out of place. I mean, I could be convinced if I came up with the right abstractions for doing it. But really, the bulk of the work is done in this parsing section and in the candidates for section. I hope that in future iterations of this kata, what I hope to be able to do is find a way to do this that is more expressive of the intent, that reads a little cleaner. Yeah, I don't have a whole lot to add, I don't think. Hope you enjoyed it, or maybe learned something, or maybe have some feedback. Thanks.